Happy snow day, everyone. I wanted to make a short video on your next assignment in the class, and also let you know that I've extended out quiz 28, the due date, until Wednesday instead of today. So what I want to show you right now is the next assignment that's going to be due on next Monday, so a week from today. It's out here on D2L. It's under assignment 4. And there's two documents or two files out here. The first is the Word document. I'll go over that really quickly. You might hear some noises in the background. My kids are also off from school today, so you'll hear them roaming around. So this is the assignment for next Monday. What I'm asking you to do is open up an Excel file. There's a macro in that Excel file that will actually calculate the value of a call and the value of a put for you. So, and I'll open it up just to demonstrate it, but you'll want to make sure to enable the macros or not disable the macros. In this assignment, I'm asking you to use data tables to demonstrate what are referred to as the Greeks. And the Greeks are the different variables that go into determining the value of a call option and the value of a put option. So you see here in the first part, you're going to create 4 different data tables to show how the change in different variables affect the value of the call option and the value of the put option. I'll do a short example of this for you. In part 2, you're going to calculate implied volatility, which is the amount of volatility or movement in the stock prices that's accounted for in the call value. And I go into more detail in the assignment in what that means. And then finally, I go through what the Greeks are and provide you with definitions of each of them. Now, it's not necessary to memorize these or anything for the assignment or for the test, but just to let you know what you're calculating above. So I'm going to open up the spreadsheet that goes along with this. So it's right here. So when I opened it up, it said protect view, be careful. So I want to enable editing. And then it says security warning, macros have been disabled. You want to enable that. Let me show you what those macros are. You may or may not have this tab on your Excel. It's developer. You can add that, and I can show you how to do that if you're interested. But you can see the Visual Basic programs and the macros that are in a spreadsheet or a workbook by pressing the Visual Basic tab. These are the macros that I've put in here. The first one is D1 or done. And I'll go through this in class too on how to calculate this. The second is D2, and you use those to calculate the call value, and we'll go through the actual calculation by hand in class, or the put value. And notice here that I'm using the call value from my previous function. So if you remember from our class before Thanksgiving, I went through put call parity, and I'm actually using it here to calculate the value of a put. You don't need to memorize this. I just wanted to show you what was going on. You can create functions in Visual Basic to use in your spreadsheets. So I'm just going to demonstrate very quickly how to complete these questions. So up here I have all of my inputs. There's 5 inputs, actually, sorry, 6 inputs: stock price, strike price, risk-free rate, volatility, time to expiration, and the dividend yield. And what I did is I looked up a call option and a put option for Tesla Motors. The date was November 23rd when I looked these up. The time to expiration was 1.15 years or 420 days. And these expire in January of 2020. I use the call value and the put value functions that I created in Visual Basic to determine the call price and the put price using the Black-Scholes option pricing model. And you don't want to change these. In fact, you won't need to use either of those functions. I've done that for you here. But for each one of these, the delta, the theta, the vega, and the rho, you need to create a very small data table here, and I'm going to do a quick demonstration on how to do that. And it's also in your previous assignments. And then down below, we're going to use, you can use either goal seek or solver to answer these questions. I'll do a quick demonstration not using these questions on how to use those tools. So I'm going to do part of this one to show you how to do this. And you might remember you did this for the bond immunization problem, and then you did a two-way table for the assignment 3. So what I put in these cells for the call price, I set this equal to the call price here. And for the put price, I set it equal to the price here. And then I'm going to use, I'm going to highlight, just going to highlight up here the first ones. What if analysis data table. My column input cell is going to be my stock price. I've labeled it here. So this tells us what happens to the change in the call value and the put value with a $1 increase. So we're going from the original price to $1 more in the stock price. So you can see here for the call, it goes from $95.99 to $96.69. And so if you read the instructions for this assignment, that's delta, and that's going to be equal to, the delta is going to be equal to the difference between the two, or 0.70. And typically this wouldn't have a dollar sign in front of it. It's just a number. And that changes, so that changes as you go through the rest of these. And what I want you to do is not just do the data table for the first one, but do the data table for the entire yellow area on each one of these, but use the first change to give me the answer for each of the Greeks. This one here looks a little strange because it's supposed to be a one-day change, and I put that in years. So even though these look the same, if you look up here, the numbers are changing based on reducing the time to expiration by 1 day. So in part 2, what we're going to do is calculate the implied volatility of an option. And what I've got down here is the call price as of November 23rd, 2018, calculated using the call value function here. But it's referencing these variables here. And here's the put value. And again, I'm using the put value function. And I'm using the values of the variables over here. And what I want to do is figure out the implied volatility using the actual option values as of November 23rd. So the actual option value here was 97.50 compared to the estimated based on the Black-Scholes option pricing model. So there's a small difference there of $1.51. And for the put value, it's a little larger difference. It's a $4.14 difference, but still a fairly close value. And we're assuming that the differences in the values are due to the difference between the historic volatility, which is this 0.5542, and the actual implied volatility by the people trading the options. So I'm going to demonstrate how to use goal seek with a separate problem here, just a quick time value of money problem. We're going to put the future value, we're going to have the present value, the number of periods, and then the interest rate. So our present value is negative 7,000. So that's how much we're going to invest. Our number of periods is 8 years. We're going to solve for the rate. And our future value is equal to future value, our rate, which is blank right now, our number of time periods, which is 8, our payment is 0, and then our present value, the amount we're going to invest, is 7,000. So now we're going to solve for the rate that will get to us to $10,000 here. So I'm going to go to Data, What If Analysis, Goal Seek. So you see this is a little bit simpler than the solver. So we want to set value 7,000 to be equal to 10,000 by changing the rate. So what we get here is an answer of 4.55% for the rate we need to go from a present value of $7,000 to $10,000 in 8 years. So you're going to do the same thing over here, where you're going to make the call price here, again, don't change this, equal to the actual price of $97.50 by changing the volatility. I hope that helps with your assignment. I will see you all on Wednesday. Please let me know if you have any questions. What we're going to do Wednesday and Friday are go over the rest of the notes for the Black-Scholes option pricing model. It's only a few pages of notes. We're going to probably get through those on Wednesday, and then we'll work through sample problems on Friday. I hope you have a good Tuesday and snow day today, and I'll see you all on Wednesday. Thanks.